Hi, my name is Jordan Daer and welcome to the Essentials of Biomechanics video, brought to you by Curl Coaching. Usually when people think about performing exercises at the gym, they mainly focus on what their muscles are doing and don't really understand exactly what is going on inside their bodies. There are other structures associated with the muscles that help support and hold things in place while we perform the exercises we know and love. Without these structures, we wouldn't be able to move at all, let alone perform exercises. Today we're going to be talking about tendons and ligaments. More specifically, what they are and how they work together with muscle so that we can perform compound exercises. So what is a tendon? As you all know, we have various different muscles and muscle groups located all around our bodies. But how do these muscles stay in place? Tendons are what connect our muscles to the bones in our body and allow us to move our limbs. Tendons also function to absorb the impact that muscles face when performing movements such as running and jumping, which ultimately prevents injury. Tendons are made up of strong, flexible tissues that pull the bones they are attached to when you flex a muscle to perform a movement. Tendons are located all over our body and come in different shapes and sizes in order to work with muscles that produce both large and small forces. Tendons are also made up of a protein called collagen, which gives the tendon its strength and flexibility as well as its resistance to damage. These collagen fibers are arranged in primary, secondary, and tertiary fiber bundles, which give the tendon the strength it needs to carry out its duty. As I mentioned before, the tendon connects our muscles to our bones, which means there's 2 points where the tendon connects. These points are called the musculotendinous junction, or MTJ for short, and the osteotendinous junction, also called the enthesis. You could probably guess by the makeup of the words that the MTJ is the point where the tendon attaches to your muscle, while the enthesis is the point where the tendon attaches to your bone. To keep your tendons healthy and functioning properly, make sure you listen to your body, warm up before exercise, stretch after exercise, and work and rest days. So what is a ligament? While the tendon's purpose is to connect our muscles to our bones, ligaments function to connect our bones to other bones in our body. Ligaments play a huge role in allowing our bodies to move properly. The ligaments have many purposes beyond just binding bone to bone, however, including allowing joints to move in the proper directions, stabilizing and strengthening muscles and joints, preventing dislocations, and making sure that our joints don't twist. To put this into perspective, think of the knee. The purpose of the knee is to allow our legs to bend forward, and when you see them bending in other directions, that's clearly a problem. The knee has 4 ligaments attached to it which carry out the functions that were just mentioned, ultimately keeping it from bending in all different ways. Like the muscles and tendons, ligaments are found throughout your body in order to provide support all around. There are more than 900 and most are located in your arms and legs. Ligaments are made up of elastic fibers that allow for a limited amount of stretch, and just like our tendons, they also contain collagen. Ligaments are very diverse in terms of their shape, size, and even color. What I mean by this is there are ligaments that resemble things like ropes, cords, or bands, but some can be thin, wide, or even arc-like to adapt to our different types of joints. The same tips I gave in order to keep your tendons healthy can be used for your ligaments as well. These include taking rest days, stretching before and after exercise, switching up your exercise routines, and of course, always taking a break if you feel any sort of pain. Now that you know what tendons and ligaments are, and how they are connected to the muscles and bones in our body, I'm going to briefly explain what goes on when our bodies are completing a movement. When completing a movement, we use multiple systems in our body to plan, carry out, and correct each movement. These include the muscular system, skeletal system, and nervous system, which I won't go into detail about. When we decide we want to carry out a movement, our brain sends signals to our muscles through our nervous system, and they either shorten or lengthen depending on the type of movement. For example, when performing a dumbbell curl, your bicep contracts and shortens when you pull your arm towards yourself, while your tricep lengthens and relaxes. The opposite happens when performing tricep extensions, which means those 2 muscles have what you call an antagonistic relationship, where one contracts and the other relaxes depending on the movement. Earlier we talked about how tendons attach muscle to bone, which is super important when it comes to carrying out a movement. Our skeletal system is there to support our bodies, so when we are performing a movement and contract our muscles, the tendons allow the specific muscles to pull the bones associated with them, ultimately resulting in a complete movement of that body part. While this is all happening, ligaments serve the purpose of supporting the joints that are involved in the movement, allowing it to stay within its range of motion. When exploring any gym, you'll see many different exercises being performed. Ones involving free weights like bicep curls or lateral raises, and ones involving benches or racks like barbell squats and barbell bench presses. The two different types of exercises you'll see are compound and isolation. Compound exercises are defined as gross movements that require activation of several muscle groups. Isolation exercises are pretty self-explanatory as they involve the isolation of one muscle group, like the biceps when performing an exercise like bicep curls. The 5 big compound exercises that you'll see are deadlifts, bench press, squats, shoulder press, and pull-ups. To give you an idea of what happens during a compound exercise, let's analyze the squat. Performing a squat requires the activation of several muscles, including the quadriceps, glutes, adductor magnus, which is your inner thigh, hamstrings, erectors, abdominals and obliques, and your calves. The amount each muscle is activated depends on the type of squat you're performing and how well your technique is. A textbook squat would have your load just over the midline of the foot. However, it's very normal to move outside of this range. When performing a squat, there is activation at your hips, knees, and ankles, which is why so many muscle groups are activated. These joints experience stress when you perform an exercise like the squat, and this stress increases on a particular joint if your load moves forward or backwards. For example, if your knees travel forward while descending into a squat, then you experience a larger amount of activation from your quadriceps in order to support your knee joint and compensate for the forward movement. Another example would be if your hips extended backwards more than they should. This would mean your glutes and lower back muscles would need to activate more instead. Overall, a compound exercise is a great exercise to add into your workout routines as they work multiple muscle groups and allow you to test your full body strength. Making the big decision to start hitting the gym regularly in order to look better, feel better, and perform better is a great start. However, it's not enough to just go through the motions for an hour or so and then go on with your life. Knowing and understanding the mechanics behind your exercises and how your body is performing them is an essential part of your fitness journey, as it allows you to maximize your gains and prevent injury. Thank you so much for listening and watching this video on the essentials of biomechanics. I'm Jordan Daer, and until next time, stay swole.